Hello everyone. I hope you are doing fine. Before we start this video, this class, I have announcement to make. After this video, all my videos will be private. Okay, so if you need to watch my video, please contact me. You have my email here and my WhatsApp here. Okay, just for your information. Sorry. So today we will continue our class of Eurocode, Geotechnical Design, and we will try to make progress on this chapter number 3. We are still on this with the worked examples. Okay, ground investigation and testing. I think the previous video also was about this same chapter, but the previous video was on ground investigation of ground parameter, or let's say it was based on lab testing. Okay, in this example, this one will focus on CPT investigation using CPT test. Okay, so still on work example. So how to obtain characteristic value of ground parameter using CPT data. Okay. And after this example, we will do another one before ending this chapter. Okay, so we will do 3 worked example on this chapter. Once again, after this video, all my videos will be private. So contact me, send me a message or email if you want to continue watching the videos. Not only this program, but all the other programs. Okay. So let me just remind you, we have seen this at the early beginning of this chapter about what is derived value and what is characteristic value. Okay. So I think I have explained this last time also as a reminder. So if you do field test and lab test, F for field, L for lab, okay, what you will obtain is derived value. These are value obtained directly from the test by just adding some correlations. Okay, so the derived value then are used to obtain characteristic value. So by using the derived value from the test, lab test or field test, adding some parameter, some information, you obtain geotechnical characteristic value of geotechnical property. So this is what we are looking for. This one. Okay. This part. And after that, please don't forget that you have to apply partial factors to obtain the design value as well. But we will come back on this type of exercise when we will start working the chapter on foundation, pile foundation, for example. Okay, in that case, we will take one example to design pile from the geotechnical parameter till the end. Okay, so now you know what we are looking for, characteristic value. This is what we are looking for. So how do we obtain this characteristic value when the field test is CPT? Okay, this is what we are going to discuss here now. So characteristic value for base and shaft resistance of pile in sand. Okay, when we want to do the design pile foundation based on the CPT data, how will you proceed? So here is an example. The building supported on 450 millimeter diameter board pile, and in medium dense to dense sand. Okay, so they're saying that this small project, so it doesn't need loading test, because normally for big project you have to do also loading test, because loading tests are the most reliable result actually. Okay, if the project is very big, you have to do, despite you have CPT, and you have to do many CPT, many tests actually, but loading test is necessary for very big, very large project. Okay, so it believed that the settlement in service will not govern the design. What does it mean exactly? It means that because when the foundation is in service, the service may say that, for example, the settlement should not be less than more than 5% pile diameter, for example. Okay, or 2%. It depends on the project. So if you don't have such constant, you don't have this kind of obligation, you can just decide that the settlement that will govern the design will be 10% displacement, 10% of pile diameter. Settlement corresponding to 10% pile diameter. Okay, so that is the information behind this, by saying that the settlement in service will not govern the design. Okay, so we have information like the CPT data here. So we can see that definitely there are two soil layers. Okay, the upper one maybe up to, I think this 16, it's not very clear, but 16 or 16.5 up to here. And then after that, there is another stronger soil layer. Okay, so we will use this CPT result, although we have only one result. Normally for big project, only one CPT test is not enough, but this is what we have. Since it is not a big project, we can do with this. Okay, so you can refer to this in Eurocode. You will see how pile are designed. So what we need is characteristic resistance for base, the pile base, pile tip, and the shaft resistance are here. The characteristic value, you remember, RBK, RSK. B means for base, S means for shaft resistance. So here is the formula you have to use. This one is for the resistance, characteristic value of base resistance, and this one is for shaft resistance. As you can see here, you have AB. This one is just the cross section of the pipe, and actually it here, AB is the cross section, and ASE is for the shaft area. Okay, it here written I because maybe we don't have, this is general formula in case you have several soil layers. So I here represent each soil layer. Okay, so if you have uniform soil, you don't need to put it because shaft will be same in everywhere. But if you have layered soil, then you have to consider additioning the shaft in each layer. Okay, that's why I have this. So these two value, AB and ASI, these are related to the pile geometry. I think you know that, right? The cross section of the pile and the area, shaft area, okay, base area and shaft area of the pile. Okay, so will depend on the geometry of the pile. That will not be an issue, I think. But this QB and QS. These are obtained from the CPT result. Okay, these are what we are calling the characteristic value of base resistance and shaft friction in various data. Okay, from the ground, these are what the ground, what we need. These are related to the ground, the type of ground we are dealing with. Okay, and these are what we need here to obtain. This is the objective of this video actually. Okay, because the other two, it will depend on your pile. You have your pile geometry and you can obtain them. Then by making this multiplication, you can obtain your resistance buff. Then I guess you know that to obtain the total resistance, total bearing capacity, you have to just make this one plus this one. That one is, I think I don't need to tell you that. Okay, then I will just skip these two formula here. Okay, I hope it's clear for you. Then there are two tables you can check in Eurocode, the part 2 of Eurocode. There are two tables that can give us QB and QS. Okay, this one is for the QB, but please be careful here. It's written PB, but it's same. Okay, B, this is for the base, and depending on the value of, they depend on the value of the cone resistance QC, which we have here for QC 10 in megapascal. Please be careful. 15, 20, 25, and also depend on the settlement. Okay, normalized settlement means settlement normalized by the pile diameter. Okay, then we have, for example, settlement 2% of pile diameter. These are the value you will take for QB, or again it's same PB. Okay. And for settlement 3% pile diameter, you have this value. 10% pile diameter, you have this value. Okay, this is for the base resistance, pile base resistance. Let's go now for the table for shaft resistance. What we have is here. Okay, just this table. So for the shaft resistance, you have also the value for cone resistance, and the corresponding shaft resistance is here. Okay, so QS, which is here, same as PS here, it's same. Okay, unit shaft resistance. So depending on the value of the cone resistance you have, you can use this table to obtain the unit shaft resistance, means QS here, or same here, PS. Okay, so these are the two tables we will use. Okay, then let's go and see what we have here as CPT result, how we can use our CPT result. Okay, Eurocode is recommending averaging the CPT value. So here, if we check, okay, from this figure, the cone resistance, maybe the pile tip is in this layer, but a good portion of the shaft, the pile shaft, is in this soil layer. So because of that, we will use this average of this portion, this part, to design the shaft, and this part, the average cone value to design the tip resistance here. Okay, so for this upper part, it means, yeah, it is 16.5 meters from 0 to 16.5 here. We have average, the average is 2.5 megapascal. Okay, because we are using the average. Okay, and beyond the 16.5 meter depths, we have this average 12, let's say 12.5 megapascal. Okay, so we will use these two averages to design to obtain the characteristic value, this QB and QS, using the table. It's very clear, I think. So this one will be used for the shaft resistance. This one will be for the base resistance. And just remember here, settlement in service will not govern the design. And I have explained what it does imply. What is the meaning of that in the beginning of this video. So because of that, we will just refer to we'll use this 0.1 times D pile diameter will be considered. Okay, but if the settlement in service is to govern the design, we have to consider that. For example, settlement in service can say, this is a very important structure. We should not allow any settlement larger than 5% the pile diameter, for example. In that case, you have no choice. You cannot use 10%. Okay, so there is no restriction about that. So we use the usual value, the usual percentage, 10%. Okay, let's go. Let's start with the shaft resistance. Okay, it's same, right? It doesn't matter with shaft or base resistance. I think you can easily understand. So for the shaft resistance, this table is used, right? So we use the upper part because the pile will be mainly in this portion. So the pile body, the pile shaft, 2.5 megapascal. So what you will do is just check here. For 0 megapascal, you have unit shaft resistance is 0. 5 megapascal, you have 0.04 megapascal as unit resistance. 10, 0.08. It's like linear, as you can see. And it even here saying that intermediate value may be interpolated linearly. Okay, so it means in our case we have 2.5. When you check 2.5, is it between 10 and 5? No, I don't think so. But it's between 0 and 5. And actually, if you see 2.5 is just half of 5. So automatically, you can even say, without even calculation, that the shaft resistance corresponding to 2.5 megapascal will be 0.02 because it is saying linearly. Okay, so from this table, we can say that the shaft QS, since it is uniform, we don't need to add the I. Okay, if we had many layers, then you can add QS in this layer, QS in this layer, and so on. Okay, please remember that. Then 0.02 megapascal for the shaft resistance. Very simple. Okay, because 2.5 will be before the 5. So it just half of 5. So you can see that the corresponding unit shaft resistance is 0.02, which is just before 0.0, half of 0.04. Okay, so after that, you have your pile geometry, you can obtain the AS, and then multiplying, you can obtain this. Very simple. Now let's go for the base resistance. For the base resistance, this table is used. And don't forget, for the base resistance, it depends on the settlement you're working on. Here, we said that 0.1 times pile diameter, settlement corresponding to that. It means 10% pile diameter, since the service settlement will not govern this design. Okay, that's why we will focus on this value, this line. Okay, it means for cone resistance 10 megapascal, we have 2, 15, 3, 20, 3.5, 25, 4. And here as well, it's saying that intermediate value may be interpolated linearly. So that make it very easy actually. Okay, so we have here for the base 12.5 megapascal. It's 12.5 megapascal. Is it, where can we put it here in this the cone resistance? Is it between 10, 15? And actually, if you check, it's exactly the middle of 10 and 15. If you do 10 plus 15 divided by 2, you will get 12.5. So because of that, even without calculation, you can automatically say that the value you will obtain, because 12.5 will be here, so the value you will obtain will be between 2 and 3. Actually, will be the exact middle of between 2 and 3. So it will be 2.5 without even calculation. You can guess that already. Okay, so our base characteristic base resistance will be 2.5 megapascal. Then if you have your pile geometry, foundation geometry, you can obtain the AB, the pile cross section. And then by additioning the two, you obtain the pile resistance. Okay, thank you very much. And don't forget, after this video, if you need to watch more, please message me or email me. The videos, they will be private from now on. Thank you very much for your time, and I'm waiting for your messages or your emails.